Welcome to the video. My name is Uppuluri Lalita Madhuri. I'm a third year undergraduate student from the Department of Mechanical Engineering, IIT Kharagpur. This presentation on design of railway ladder modeling is a part of group assignment of the course ME29002 Mechanism Sessional for academic session 2022 to 2023. Next slide. My teammates for this group assignment are Ayushman Agrawal and Arnava Sarkar. Next slide. Let's go to the problem statement. The problem statement which we have selected is the design of railway ladder system. The exact problem statement is a railway ladder system is being contemplated for ease of accessibility to train coaches from platforms of different levels. We have to synthesize and make a simulator for the ladder with any new ideas you might have, like automating the opening or retraction using a motor, locking mechanism in a retracted position to take the load off the motor, etc. Next slide. The further applications of this mechanism can be used in different scenarios, like retractable stairs of an aircraft, while we can use them while landing, and stepping platforms of toll trucks and similar vehicles.
Hi, my name is Arunava Sarkar, roll number 20MF10047. I am a third year undergraduate student of the Department of Mechanical Engineering at IIT Kharagpur. So we started designing the basic double rocker mechanism, which is based on the non-Grashof criteria. Therefore, the sum of the lengths of the minimum link and the maximum link is greater than the sum of the lengths of the remaining two links. We have put a short animation so that we can explain the terms that we have mentioned before. As seen in the animation beside, the red link, which is the longest link, is the fixed link, and the blue link, which is the shortest link, acts as the rocker, and accordingly the green link also acts as a rocker. Thus, it forms a double rocker mechanism which exhibits two extreme positions, which are also called dead center positions. These dead center positions will correspond to the open and the closed positions of the stairs. Therefore, while synthesis of the mechanism, we use this displacement of the rockers to enable the opening and the closing of the stairs. For the modeling and simulation, we have made use of SolidWorks. It is a solid modeling computer aided application which is published by Dassault Systems. And now my friend Ayushman will explain the models and show the working of the models in the simulation.
Hello, my name is Ayushman Agrawal. I am a third year undergraduate student of the Department of Mechanical Engineering at IIT Kharagpur, and my roll number is 20ME10028. So this is the 3D model that we have prepared for the railway ladder simulation, and it's currently in the closed position. And now we are going to see how we build this model, and also we will understand the working of this model. So now first let's start with the various parts of this model. So at this there is a rectangular boundary, or basically this is the fixed part on which the mechanism and the steps are attached. So and also the first step is attached to this frame, which means the first step is also fixed along with the complete frame. Now let's see the different parts. So this is the first step, and these are the small links. And now let me introduce how I made this parts. So this step was basically made using a rectangular sketch that was extruded, and then I filleted this at both the ends, and then I made a copy using the array function of the SolidWorks to make similar 5 more steps. Now this boundary frame was also made using a similar rectangle, and then it was extruded to make it into this kind of a frame. The links were made using the slot function, and this was made using the shaft function of the SolidWorks. Now let's see this model running, and let's see this model how it simulates. So when we open this shaft, basically the stair opens, or basically the stair it kinds of unfolds. Now as we can see, this is the opening and closing mechanism, and it can also be controlled with this. Yeah, so this is how the slider would function. The maximum position can be this, and the minimum can be this. Now let's understand the mechanism of it. So as previously mentioned by Arunava, this is a double rocker mechanism. That is, we have two rockers, and they are basically in a non-Grashof criterion chain, because we are not, because they have two dead center positions, and we are not rotating any link completely. Basically, we are not cranking any link. So yeah, so basically this ladder and the frame are form the ground link, like from this part to the ladder. So this is the first ground link, and as you can obviously see from the geometry, it is the largest link. So this ground link is the L max, and then this small link is the L minimum, and it is used to basically drive the ladder opening and closing. And these are the two links that join both the ground link and the this driving link. So this can be thought of as this can be thought of as the coupler, because it attaches to the one side to the link with the ground link, and other side to the driving link. And this is basically in the form of a shaft that kind of that goes in and comes out into the this link, or basically this link, which you can call as the hub link, or like the hub which facilitates this shaft. So when we move this link, the shaft goes in, it follows this path, like as you can see this blue kind of boundary line, it follows there, and this link moves up, and this hub link moves up and down with very minimum position. Yep. So this is how the mechanism of the ladder works. Now coming to few areas where we can improve this ladder. So here I wish to like introduce a locking mechanism. So we could have we plan to introduce a nut and bolt kind of thing that can be used to lock and unlock this mechanism, and keep the ladder in a particular position. And also I would like to mention where we can use this, like where this mechanism can be deployed. So basically it can be put below the carriages of the trains, and there can be a button at the entrance that when pushed will release this mechanism, and the slider and the stairs would come out. Also we could attach a differential actuator, which would basically help in opening the stairs at different levels. So it can be helped to open part of the stairs, and part of the would be retracted. So these are the few areas which we thought that could be worked out, but due to but we couldn't include that because of complexity in the SolidWorks simulation. But we will definitely try it in future. Yeah, that's it for my side. Thank you.